Hello, this is Najib again, and in this video I will show you how to implement stacks with C++. We will use linked lists, of course. Okay, so you don't need to write anything because later you can download my code. You will find the link in the descriptions below. So in this video, we will code these three functions: push, pop, and show. Here show just to show the list, the stack. Okay. So that's just the global structure of our program. Before I start explaining this code, here I want just to suggest you to go and subscribe in this online website. There is a bunch of small freelancers. They code for you any program you want. For example, for this, he say I will code C++ programming task and project for you, and this is just for $5. And there is many online freelancers here. They code any program with any language you want. Okay, so just access. You will find the link in the descriptions below. Access to this website and subscribe for now. So let's start our program. Here we say we have these three functions, and here we just have, so that's an act. So here we say that's a variable in integer. Here we say to push. If you want to push a new element, press 1, and to pop, press 2. So you will make this variable 1 if you want to push, and 2 if you want to pop. And here I have this switch block. So switch with act. So if you make this variable equal 1, so here we call the function push. And if you make it 2, we call the function pop. And in all cases, when we finish this switch, we show our stack. Okay. So now in this video, we will write these three functions. So let's compile. Let's compile for now, just to see how this structure works. So here to push, press 1, and to pop, press 2. If you press 1, so you push. So here this function for now, push, is empty because now we didn't do anything. And here we show the stack, showing the stack. We print this thing here, and we call the function show. If we choose 2, so we pop. Okay, so let's now just focus with these three functions: push, pop, and show. Before we code here, we want to declare our structure, our data structure. Here, for example, that's stack. Here we push. So I assume that you know the global idea of the stack. Okay, so here if we push, and here we pop. So we want to declare this structure here. Okay, so let's declare it. So let's imagine that we have clients, and the last one he is the first one. The last come, the first out. Okay, so let's name it client. Our structure, we name it client. And so the client, he has just a name, so that's a string name. And we have the next pointer to the next client, okay, because that's a linked list. So client next. Okay, so what we do now we want to declare our first our first member. Okay, our first member, and we initialize it with null because initially our stack is null, is empty, and because we use linked list, so that means that the first pointer is null. Okay, so we declare our stack as a null linked list. Okay, so we just declare client, we name it stack. Okay, and we make it initially equal null. That means that our stack initially is empty. So let's now go and use this code this function push. Push what's mean? So we have two cases. So let's first create our new client. So let's declare a new pointer C. Let's initialize it by null, and here I will create this client. So C equal new client, and at first we want to enter the names. We want to give a name for this client. Okay, so here I just say cout the name of the client, and so I put this name into this new element name. So that's C name. Okay, so now we have created our new client. Now we want to link it in our stack. Okay, so there is two cases. The first case, if our stack is null, so we make the stack equal this new member. Okay, if our stack is null, so how to know if our stack is empty? I check if this stack is still equal null. Okay, so if stack equal, no, it's stack with U, I think. No, with A. If stack equal null, in this case I just make this stack, this the first element in this stack equals C. That means that the stack variable, so stack equal C. That's simple. And the next of this element must be initially equal null. Okay, that's a big problem if you forget that. Okay, so I make this the next is equal null. So that's in the case if our stack is empty. So else, if our stack is not empty, so what we do? So we want to go to the last element and link our new element with the last element. Okay, so how to know where is the last element? So we start from the stack. So that's the stack, our stack, the first one, this element here. And when we find the next of this element is equal null, that means that this is the last one, because this is the next of this element is this, the next of this is this, the next of this is this, and the next of this element is this element, and the next element of this is equal null. That means that this is the last one. So we link this new element with the element which the next of this element is equal null. Okay. So how to implement that? So we just declare another pointer. Let's name it C1, and so for C1 equal the stack. So that means the first element of the stack, and C1 next is different than null, because if the next of this element is null, that means this is the last element in the stack, the topmost element in the stack, if C1 next is equal null. Because that I want to stop when I find the next of this element equal null. Okay, and the step is C1 equal C1 next. So I don't do anything here because I just want to cross over the stack. Okay, so and here just when I finish, so I finish this loop when C1 next is equal null. So here I just make that C1 next equal this element I have created here equal C. Okay, so now when I run, so let's choose one here, enter the name of the client, Najib for example. So this element is entered, but here I didn't see anything in our stack because we must fill this function here. Okay, so let's code this function. Okay, so here we just want to showing our stack. So we just create a pointer, and I just make, let's name it C1 like this loop here, and I make the condition if C1 equal where C1 is different than null, we just show our client name. Okay, so let's compile now. So let's enter AlgoLancer as my channel name. So we have showing the stack, so that's the first, that's the bottom member of our stack. Let's enter another one, so Najib, so that's the second one. So here we show our stack from the, so the first, so the base, the first element is on the top. Okay, the inverse of this case here, so that the first one is in the bottom and go to the top. In my program is the inverse, so the first is here, AlgoLancer, and then the second one, and then for example if I will write this name, so that's the last one, so that's the first element, and that's the last client who entered in our stack. Okay, so let's now go and we'll write the code of the pop function. So in the stack, so here I want just to show what I want in my program. When I pop, I just show the name of the client and I remove it. Okay, but that's not good for the practice, because in the stack we want to make this function return this element, so it's drop it from the stack and return it. Okay. So because that I want to make this function returns a pointer to the popped element. Okay. So and here client, let's name it C2 equal this element, because here I want to pop, I remove this element from the stack and I return it here. Okay, don't just remove it in the pop function. So so what we do in the pop function, we remove the last element in the stack. So there is three cases. The first case, so if our stack is empty, so in this case, so if our stack is equal null, so in this case we just return null pointer. That means that the stack is null. The second case, if we have only one element, if we have just this and the next of this element is null, so in this case we just return this element and we make the stack is equal null. Okay, so in this case, so if the stack, how to know if we have just one element in our stack? We know that if the next of the stack, if the next of the stack is equal null, in this case we return, so we return the stack itself or here, so let's declare a new element. So here I make this C equal the stack and I return this element which is equal the stack. But before I return, I must make the stack equal null. Okay, I make this pointer equal null and I return this C here. So else, here I don't use else because I use the keyword return, because when I call the function the keyword return, I stop the function, because that I don't use else here. Okay, so here what we have here, that's mean if I reach this line here, that's mean that I have at least two members in our stack. So here in this case I just use a while loop. So let's use this C here, because if I don't use it here, I use it here. Okay, if C is different than null, so that's while loop. Okay, so how to know that if this is the last element? So we say that the last element is the element where the next of this element is equal null. Okay, so while C next or let's just use for loop. Okay, for c equals stack and c next is different than null, and the step is equal c next, because here, excuse me, I don't search for this for the for the last one. Excuse me. Here I don't search for this. I search for this, for the element where the next element is equal null, because that I want to make c next. Okay, and here what I return, what I do. So here let's declare another pointer c1. Okay, here I just make c1 equal c next. Okay, and then I make c next equal null, and then I return c1. So let me explain. So here in this case we say that if we reach here, that means that we have at least two members in our stack. So what we search for this, because I want to return the next of this element, and I make the next of this. So I want to return this, and then I make the next of this element equal null. So the first thing, I want to search for this one. So this one, I know I get this when the next is equal null, because that I make here this condition. So I stop when c next equal null. Okay, when I finish only in this member. When I reach this member, I finish. So what I do, so I declare another pointer here, and I return this element. So because that I make this c1 equal c next, and then what I do, I make the next of this element equal null, and then I return this element. Okay, I make the next of c equal null, and then I return c1. So here what I do here, I check. So we said that this c2 may be null. Okay, so here we just print c2, and then we free this member. Okay, so here, so c out. So that's if c2 is not null. Okay, so if c2 so if c2 is different than null, here here we just show the popped, so cout the popped element is, and we show the name of this to C2, okay, C2 name, okay, and here we free C2. So else, if else, we just say that this is an empty excuse me, stack is empty. So let's compile. So let's add element. So Najib, let's add another one, AlgoLancer. Let's add the third one, Algeria. Excuse me. So here I choose. So I must choose one. Excuse me. I will compile again. Let's choose another name, Algeria. Choose another. Let's choose another. So that's our stack. So let's pop now. When we pop, we press 2. Okay. So the client with the name AlgoLancer popped from our stack. Let's pop another one, and let's not pop. Let's pop again. So now our so here I choose one. So I want to enter another client. So now we have Najib and A. Let's pop. So this name was popped. Let's pop again. So now our stack is null. Let's enter. So we have this name now. Let's pop. So that's it. Notice that you can download the code. So that's it. Don't forget to subscribe to this website, and see you later.